So in this video I'm just going to run through some problems that we've experienced in CC9, and that typically revolves around Avogadro's constant. General rule, if they give you Avogadro's constant in the question, you need to use it. If they don't give it to you, you don't need to use it. And this is the formula that contains Avogadro's constant. So you'll be asked about how many particles. They won't use the word particle. They'll either use the word atoms or ions or molecules, and it will depend what they're talking about. So if they're talking about CO2, CO2 is a molecule. So they'll say, how many molecules do you have in this number of moles of CO2. If they were talking about an ionic compound is made of ions. So they'll say, how many ions do you have in this number of moles of NaCl? If they're talking about something that's made of atoms, they'll use the word atoms. So it's going to be one of these three words. They'll tell you the number of moles. You take the number of moles and you multiply it by Avogadro's constant. So we will look at one or two examples. All right, they could say, how many atoms in 3 moles of carbon. Okay, so I'm using the word atoms because carbon is made of atoms. If I've got 3 moles of it, the word mole represents the number 6.02 by 10 to the 23. So it's going to be 3 multiplied by this number. If I change that to 5 moles of carbon, then it would be 5 multiplied by that number. If I used a decimal, if I had 6.5 moles, it would be 6.5 times that number. I change this to something else. Instead of talking about carbon, what if I was talking about CO2? If I'm talking about CO2, CO2 is a molecule, so the question will read, how many molecules do you have in 6.5 moles of CO2? And the calculation is exactly the same. You've got 6.5 moles, and you multiply it by this number, which represents the word moles. They could also ask you about a different molecule. They could change that to NH3. Again, doesn't change the calculation. NH3 is a molecule. If you've got 6.5 moles of it, it's 6.5 times that number. The only time it gets a little bit trickier is if they give you something that looks like this. Let me rub this out. If they say, how many atoms do you have in 4 moles of CO2? Because in this case, they're asking you for atoms, but they've given you something that is a molecule. CO2 is a molecule. Okay, I can't find CO2 on the periodic table, therefore it's not just a single atom, it's a molecule. And what I have to do in this case is I need to first of all work out how many molecules of CO2 I have. Okay, so first thing I want to work out is number of molecules. And to do that, I'll do exactly what I have been doing. 4, because I've got 4 moles, multiply by the number that the word mole represents. That will tell me how many molecules I have. And once I know how many molecules I have, to find the number of atoms, I'll take the number of molecules. Let's just say we had 10 molecules of CO2. And I'll ask myself, how many atoms does each molecule contain? Well, a molecule of CO2 contains 1 carbon and 2 oxygen. Each molecule of CO2 contains 3 atoms. So once I know the number of molecules, I'm going to be timesing it by 3. So work that out and then times it by 3 because I've got 3 atoms in each molecule. If I were to change that to a different molecule, let's just say I had ethane, C2H6. Okay. First of all, I'm going to work out the number of molecules of ethane I have. So I'm going to do 4 times 6.02 by 10 to the 23. Once I know how many molecules I have, I need to look at how many atoms each molecule contains. I've got 2 carbons and 6 hydrogens. I've got 8 atoms in total. So I'm going to be timesing this answer by 8. So it'll be 4 times Avogadro's constant to work out the number of molecules, and then times 8 to work out how many atoms I have in each molecule. Another thing that they can do is they can ask you about ions, and then this just tends to don't ask it often, but they could. So I'm just going to do 1 or 2 questions on this. How many ions are in 4 moles of, say, NaCl? NaCl is an ionic compound, so it's made up of ions. That's why I'm using the word ions when I'm talking about NaCl. And when you're doing this, you have to treat it the same way as what we saw before. You almost have to consider that NaCl is a molecule. So you do 4 times Avogadro's constant first off to work out kind of how many NaCl molecules you have. Now I know NaCl is not a molecule, it's a giant ionic lattice, but you do treat these calculations in a similar way. So you're going to work out how many NaCls you have, and then in each NaCl you've got 2 ions. You've got a sodium ion and you've got a chloride ion, so at the end you're going to be timesing it by 2. If I change this to a different ionic compound, let's just say I had copper chloride, again I'll be doing 4 times Avogadro's constant because I've got 4 moles, but this time each CuCl2 contains 3 ions, a copper ion and 2 chloride ions, so I'll be timesing by 3 at the end. One more type of question I'll have a look at here. I'm going to specifically ask you not how many ions in total, but I want to know how many Cl- ions I have in 4 molecules of Cl2. So, sorry, in 4 moles of CuCl2. So I work out how many CuCl2s I have, okay? And then I look at my CuCl2, how many chloride ions are in each CuCl2? Well, there are 2. So I'm going to be timesing by 2 at the end. So when I asked you about how many ions total, I was timesing by 3 because there are 3 ions in total. But now I'm specifying Cl- ions. I'm only timesing by 2. If I asked you for how many copper ions, how many Cu2 plus ions, I would just then be timesing by 1. There's only 1 copper ion in each of the CuCl2s. Again, general advice with these types of questions: if you're given Avogadro's constant, you have to use it. If you're not, you don't have to use it. The other place that it's relevant is if they ask you to calculate the mass of one atom. And I'm going to show you where this formula comes from, but then ultimately, if you just learn this formula by heart, you should be absolutely fine. I'm actually going to do it on my whiteboard instead. Alright, so we all know our mass, formula mass, moles triangle. Alright, and I'm going to do this for calcium. Calcium has got a mass number of 40 and atomic number of 20. So let's just say I have got 1 mole of calcium and I want to work out the mass. So if I've got 1 moles, I have got 1 times the formula mass of calcium is just 40. The mass is 40 grams. All right. So if I have got 1 mole of calcium, I have got 40 grams of calcium. But we need to remind ourselves what 1 mole is. 1 mole means I've got 6.02 by 10 to the 23 individual calcium atoms. And all of those atoms together have a combined mass of 40 grams. The question asks you, what is the mass of 1 atom in grams? All right, so 6.02 by 10 to the 23 calcium atoms, because that's how many atoms are in 1 mole of calcium, and we said we had 1 mole. This number of calcium atoms has a mass of 40 grams. What is the mass of just 1 calcium atom in grams? Okay, and it's going to be 40 divided by 6.02 by 10 to the 23. So whatever the formula mass is goes on the top, and you're dividing it by Avogadro's constant. Again, to make sure you're doing this one right, a handy hint, all right? The mass of a calcium atom in grams should be absolutely tiny. So if you do this calculation and you don't get something that is a tiny, tiny number, you know you've made a mistake. So if I use my calculator, 40 divided by 6.02 by 10 to the 23, my answer, if you see here, is 6.64 by 10 to the minus 23. That minus tells me the number is absolutely tiny, and that is what I would expect for the mass of a single atom in grams. If you got confused in your exam and you took the Avogadro's constant and divided it by the formula mass instead, if you did that calculation the other way around, you get an absolutely massive number, 1.5 by 10 to the 22. There's no minus there. That number is huge. And it doesn't make sense that one single calcium atom would have a mass as big as that. So that is going to be incorrect. Okay, if you're asked for the mass of an atom in grams, you take the formula mass of that atom and you divide by Avogadro's constant. So if I wanted the mass of sodium atom in grams, formula mass of sodium is 23. I do 23 divided by 6.02 by 10 to the 23, and I work out what the mass is. If I was asked for the mass of a hydrogen atom in grams, formula mass of hydrogen is 1 divided by Avogadro's constant. And they're the only two types of questions where Avogadro's constant is used. And again, it'll be obvious they want you to use it because they'll give it to you in the question. Only other thing I wanted to say from CC9, it's occasionally been a problem, is with empirical formula. Generally, you're all fine at calculating empirical formula, but one mistake that often crops up, if I ask you for the empirical formula of, let's just say, calcium oxide, and I gave you information about calcium, and you've also got your oxygen, and let's just say I give you the mass, and you're going to draw your little table and you're going to try and work out the moles. So as I say, I told you that you had 80 grams of calcium, and I told you that you had 32 grams of oxygen, and then you're trying to work out the formula mass, and you know the formula mass of calcium is 40 because it's the big number next to calcium in the periodic table, so you can easily work out your moles. And then you're getting here to the formula mass of oxygen, and what a number of you do is you think to yourself, oh, I know, oxygen is diatomic, therefore the formula of oxygen is O2. And then you take the mass number of oxygen, which is 16, and you times it by 2, and you write in that the formula mass of oxygen is 32. That is incorrect, okay? Oxygen is diatomic when it is an element. You're asked to calculate the formula of calcium oxide. In calcium oxide, oxygen is part of a compound. It is bonded to calcium. Oxygen does not have to be diatomic when it is in a compound. So you do not apply the diatomic thing. You always just take the formula mass of 16 for oxygen. Same with any of the diatomic elements. If I was doing this for chlorine, I would just take the formula mass as being 35.5. I would not multiply by 2 because chlorine is only diatomic as an element. And when you're calculating empirical formula, you are always dealing with compounds, and the diatomic thing does not apply. They're the main mistakes that I've spotted with CC9. Having said that, there's no quick fix with your calculations. The best way to get good at them is lots and lots of practice. It's not really a topic that you can cram for or learn things off by heart for. So if you know that you're not particularly strong with your calculations, just go back and do lots of practice. There's always going to be lots of maths questions on your chemistry paper, most of which will come from CC9 and SC14. So please do pay them the attention that they deserve.